Section 7.2, multiplying powers with the same base. To multiply powers with the same base, you add the exponents. So as long as they have the same base, you can simply add the exponents together to create your new exponent or exponential expression. So let's look at the example b to the 7th times b to the negative 4th. Since both of our bases are the same, they're b, we add the exponents together. So 7 plus negative 4 gives us 3, so we end up with b to the 3rd power. So let's look at a few examples here. We've got 12 to the 4th times 12 to the 3rd. Our bases are the same, they're both 12. So we're going to take 12 and we're going to add the exponents together. So that means we end up with 12 to the 7th power. In question 2, same idea. We have bases of x. So we have x squared times x to the 7th. We're going to add our exponents together. So 2 plus 7 gives us x to the 9th power. And then in question 3, same idea. We have bases of 9 for all three. Since we're multiplying them all together, we're going to add the exponents. So you've got 9 is your base, and you've got negative 3 plus 4 plus 8. Well, negative 3 plus 4 is 1. 1 plus 8 is 9. So you've got 9 to the 9th power. So same kind of examples here. We're trying to add the exponents of like-based items, but I've added an additional piece in here. Now I have to take care of coefficients, or items out in front of our bases. And in order to deal with the coefficients, you're going to multiply coefficients together. So in this case, for the first problem, I'm going to multiply 4 and 9 together. So that means I've got 4 times 9, and then I'm adding the exponents on the like-based items. So 5 plus negative 12. Well, in this case, 4 times 9 is 36, and I've got z to the negative 7th power. Well, I don't want negative exponents, so from the previous section, when I have negative exponents, I have to drop it underneath, or in this case, put it in the denominator, and make my exponent positive. So now I have 36 over z to the 7th as my final answer. Example 2, same thing. We're going to multiply our coefficients. So we've got 6 times 3. And then we've got b, and then we add the exponent, so 7 plus negative 4. 6 times 3 is 18. 7 plus negative 4 is 3. So I've got 18 b to the 3rd. In question 3, I'm going to multiply all of my coefficients together. So I've got 2 times 9 times 3. And I'm adding the exponents on the like-based items. So for a, that's 1 plus 2. And there's only one b, so I just put b to the 4th here. So 2 times 9 is 18. 18 times 3 is 54. A to the 3rd, b to the 4th is our final answer. Question 4, same idea. Multiply your coefficients. So that's going to be 5 times 3. And you add the exponents on your like-based items. So 4 plus 9 plus 1. Well, that's going to give us 15 x to the 14th power. Same thing in example 5. You're going to multiply your coefficients. So you've got negative 4 times 7 times 2. And add the exponents on your like-based items. So c is 3 plus a negative 2, and then you have d squared. So your final answer should give us negative 56 c to the 1st, d to the 2nd power. And then question 6, multiply your coefficients. Well, the only coefficient we have here is 12. And then we add the exponents on our like-based items. So 2 plus 1 for j, and then k is to the negative 2nd. We don't want negative exponents, so we need to simplify this. So we have 12j squared on top, and then we drop the k to the 2nd underneath in order to make the exponent positive. And so this is our final answer. For questions 1, 2, and 3, we're going to put these into our graphing calculator and evaluate. So 81 to the 1/4 power. So if you're going to enter this in your calculator, you'll type 81. You have the up caret on the calculator. It's the up caret button. And then you're going to put parentheses 1 divided by 4. And then you'll hit enter. And this is going to take 81 to the 1/4 power. And you should get 3. For 2, you'll do the same thing. You have 25, the exponent button, and then the 3 divided by 2 in parentheses, and you should get 25 to the 3/2 power is 125. And then for question 3, same idea. 27, the exponent button on the calculator, divided by 2, or raised to the 2/3 power. And in this case, you get your value to be 9. So the last 3 examples here want us to simplify, and they've incorporated the idea of these parentheses. But in reality, these parentheses are just extending the idea of multiplication. So they really don't play much of a role here except to break up how the problem's being multiplied. So it's all multiplication, so we're just keeping the same rules we were using in the beginning of the notes. So we're going to take and multiply our coefficients. So 2 times 3 times 5. And then we add the exponents of like-based items, so a to the 1st, and then a to the 5th. And then we've got b to the 4th, and b squared. And so then we simplify as best we can. So 2 times 3 is 6, 6 times 5 is 30, and we get a to the 6th, b to the 6th power. And we're done. Example 2, multiplying our coefficients. So 4 times -2 times 3. We'll add together the exponents of our like-based items, so x to the -5th plus x squared, and then y to the 3rd plus y to the 7th. And so we'll simplify this. We get 4 times -2 is -8. -8 times 3 is -24. We get x to the -3rd power, y to the 10th. We don't want negative exponents, so we'll bring the x to the 3rd underneath. So we should get -24, y to the 10th, x to the 3rd. And this is our final answer. Question 3, same idea. Multiply your coefficients, so -1 times 6 times 2. Then you add the exponents on your like-based items, so m to the 12th plus m to the -8th. And then you've got n to the 1/2 plus n to the 3/2 power. And you'll simplify this the best you can. So -1 times 6 is -6. -6 times 2 is -12. And 12 minus 8 is 4, so we've got m to the 4th. And 1/2 plus 3/2 is just 2, so you get n squared. And that is your answer.